Okay, and the suggestion that I'm making for these types of questions, where you, instead of just x squared plus or minus a constant square, if you have like something times x squared, my suggestion is let's use this substitution. Let's 2x be equal to, what is a sine theta, a cosine theta, etc. And how did I come up with 2x? Basically, that 4x squared is the perfect square of 2x, right? So instead of saying let x be equal to something, we're going to say let 2x be equal to. Now, what would you use, secant, tangent, or sine in this case? Secant is the variable squared minus the number squared. A secant theta. And what is our a here? A is 1 because the square root of 1 is 1. So it's going to be just 1 secant theta. So the main difference is this 4x squared up here. And we're going to start by writing it as let 2x be equal to secant theta. If you had something like this, x squared minus 1, you would say let x be equal to secant theta. If you have 9x squared minus 1, what would you say then? Let 3x be equal to secant theta, etc. There are other ways of doing it, but I find that this makes it the easiest to reach the final answer. Okay, so with that, x is equal to 1/2 secant theta. And as always, what is it that I need to find next? Dx. And by now we're very familiar with the derivative of secant, right? Secant theta, tangent theta, d theta. So we come back to this integral. We're going to replace all the x's with the theta, starting with the dx. I have a 1/2, which I'll factor outside. That's secant theta, tangent theta, d theta on the top. On the bottom, okay, I need 4x squared minus 1. Well, I already know what 2x is, right? 2x is secant theta. So what do you think is 4x squared? If 2x is secant theta, basically square both sides of this equality, so you get 4x squared is equal to secant squared theta, right? That was the reason of making this substitution actually in the first place. So instead of 4x squared there, I'm going to put secant squared theta minus 1 is already in there. Now the original integral I can be written as 1/2 times. Okay, in that denominator, what can I write to simplify that expression? Secant squared minus 1 is tangent squared comes out the square root as a tangent, right? And that cancels with the tangent on the top. So we're in a position to integrate secant theta d theta. And we've seen this before, right? This is not something you have to memorize, but know where to get it. Any questions up to this point, and also any suggestions about the integral of the secant function? Feel free to look it up in a table, in a formula sheet. This is something you did not have to memorize, but know where to get it. Any questions, first of all? And Willie, I think your suggestion is correct. What did you say for the integral of secant? Exactly, ln of secant theta plus tangent theta plus c, because there is no limits of integration. Again, this was on your sheet that I gave you on the first day of class on integration formulas. And all we need to do is get rid of the theta by doing a triangle. Now, to do a triangle, we know that x is equal to 1/2 secant theta, or secant theta. Let's do it this way. Secant theta is 2x, right? You can look at that as secant theta is 2x divided by 1. So how would you label the size of this triangle? Secant theta is 2x divided by 1. So where would you put the 2x? Secant is hypotenuse over what? Adjacent. So now we have secant is equal to 2x over 1. Because again, you can look at 2x as 2x divided by 1. So hypotenuse should be 2x. And adjacent should be 1. What does that leave you with the third side? The square root of 4x squared minus 1. What we need right now is two things. We need Joshua? On the triangle?
Yeah.
How did I get the size of the triangle? Let's try it one more time. Basically, this line right here was my original substitution. You always go back to the original substitution to get the size of your triangle, right? So what we had there was we had secant theta equals what? Secant theta equals 2x over 1, right? And what do we know about secant? It is hypotenuse divided by adjacent. So that's how I got the size of my triangle. Hypotenuse is 2x. That's what I have up here, right? And adjacent is 1. If you label this angle as theta, that's the hypotenuse, and that's the adjacent side, right? And the third side, of course, we get from the Pythagorean theorem. Okay, now I need to know, based on the previous step, secant theta. Well, we already know secant theta, right? What was that? What was secant theta equal to? 2x. And how about tangent theta? Tangent is opposite or adjacent, so it's going to be the square root of 4x squared minus 1 divided by 1, which is, not worth even writing down, right? So, and then plus c. Close the absolute value plus c. And there's one more example that I want to give you a hint on, and this is one of your group activity questions. It had to do with the exponential function, but somehow you can use trig substitution for these questions. It starts very complicated, or it looks complicated, but with one simple substitution, you can actually make this question much easier. And I even gave you a hint, I believe, on that group activity sheet. I said, let u be equal to, does anybody remember? Let u be equal to e to the t. Garrett, you're right, e to the t. So then du is equal to what? This is the easiest function to differentiate, right? Derivative of e to the t is itself. So now how would you rewrite this integral? On the top where you see an e to the t dt, what would you replace that with? If u is e to the t, du is e to the t dt. So clearly, e to the t dt can be replaced by, very simply, just by du, right, on the top. So the top, we converted the t's into u's with just putting a du there. We get that done. On the bottom, 1 plus. Okay, now what can I write for e to the 2t? And I want to remind everybody, e to the 2t is e to the t to the second power, right? Because when you have the power of a power, you multiply the powers. This is the same as e to the 2t. So what can I write in there instead of e to the 2t in terms of u? U squared. And don't forget, on the outside of everything, you have a power of 3/2. So now this is a lot easier looking. You can use trig substitution on this. I'm going to let you finish the rest, but let's just talk about the very next step. You would let u be equal to what here? Let u be equal to a tangent theta, right? And what is our a? A is 1. So basically at this point, if you like, put x's instead of the u, because you've been working with x's, it really doesn't matter. Now this is a typical trig substitution question. No e to the t's are involved. Do it your regular method. Get the u back in there at the end. But at the very last step, if your answer has a u in it, make sure that you replace the u with e to the t at the very, very last step of this question. I will write down my suggestion. Once again, the suggestion is let u be equal to, what was the suggestion? Let u be equal to what? A tangent theta. A is 1, so let u be equal to tangent theta. So what would you do next? Find du, right? Just like any other trig substitution question. Du is secant squared theta d theta. So your goal should be in this next integral, you just want to see thetas in there and nothing else, no u's. So, clearly u du will be replaced with this. On the bottom where you see a u, put tangent theta, etc. You're going to be able to simplify this and go from there. So I think with that hint, you'll be able to get this question.